Hello friends. So in this video we are going to learn about how we can delete the very first node in a single circular linked list. So we have till now we have seen how we can insert a new node at the beginning or at the end of a single circular linked list, and insertion at any position P apart from the beginning and end would be similar to the one we have already learned about in a singly linked list. Like insertion at this point would be simply the same as we do for a single linked list. Now, let's say this is a linked list, and of course, if it is a circular singly linked list, then the last node is going to always point the first node. Okay, now let's suppose we have to delete a node at the beginning of this linked list. Okay, so the very first node. So we can't just go and delete the very first node, because the first node address is also contained in the last node of the linked list. Hence, if we want to delete this node, we need to traverse up to the last node of the linked list and update this pointer to be pointing to the this particular node, or of course the address contained in this node, right? So for example, currently we have our head pointing to the first node. So if we have to delete this node, then definitely we need to break this pointer, we need to break this pointer, we need to point the head to this new position, of course. And apart from all of these, we need to update this part. We need to update the head to be the new head of this. Okay, so let's perform this with the operations. Okay, so let's say we have a function void delete at beginning, let's say. And since this is a single circular linked list, so SCLL, and here we are going to pass on the node pointer head. Okay, this head is going to contain the address of the very first node. Right, now since we have to delete at the beginning and also update the pointer at the end, so definitely we need a temporary pointer, node pointer, let's say Q, which we will be using for the traversal. Now we need to check for this condition, like if head equal to null, that is there are no nodes in the linked list, then definitely we are going to print the printf the list is empty. Okay, now let's say we have checked for this condition. The next thing we are going to check about is, let's say if there is only one node in the linked list, so there is no need to update anything, else if next of head equal to head. We are not checking for the null, because even if there is only one node in the list, it will be pointing back to itself. So if the next of head equal to head, then there is only one node in the linked list. So we are going to free the head, and of course we need to put null in this head pointer. Okay, now this is for when there is one node in the linked list. Okay, so when we have a single node in the linked list, we are going to do this. This is if the list is empty. Okay, if the list is empty, that is if head equal to head, right? Now, if there are two or more than two nodes in the linked list, okay, then definitely first we need to traverse up to the end, and then we need to update the pointer there. Also, we need to delete the very first node. So let's say we have these two pointers, let's say. Okay, and one more thing, we have this pointer Q. So let's say if Q points to here, and we will keep on traversing till next of Q equal to head. Now this Q points to here. Okay, so if the q points to this position, we need to update this to what? We need to update this to the address contained in the first pointer, right? Like in the first node, we need to update it to 200, of course, so that it is going to point to this node, right? And till that, we can after updating this, we can move on. So for this pointer, for we can write it as next of head. Okay, so if this next of head points to here, so initially our head is at 100 and the next of head is at 200. Okay, so keep this in mind, otherwise we need to take one temporary pointer for that, right? So if there are two or more than two nodes in the linked list, then definitely q points to the head, and we need to move q while q next of q not equal to head. Okay, till that q equal to next of q. Is that clear? Now let's say q next of q is equal to head, that is if we are at the very last node of the linked list, then what we need to do, we need to update the next of q equal to the next of head. Okay, head is currently at 100, so the next of head will be 200. Okay, and we need to update the head as well, head equal to the next of head. Okay, and the third step we need to do is we need to free the head. Now if we are not freeing, so what will happen that we are going to move this head to this point, right? So before moving to this location, we need to free the head. Okay, so if we are getting rid of this and we are updating the next of head, I mean this part to here, so that definitely we are going to miss something, right? So let's say we have put the next of q equal to next of head. Okay, and we are making the head to the next. So before doing this, we need to free the original head, right? The original head was at 100. So before doing that, we need to free the space for 100. We need to break all those pointers to 100. So that could be done only by deallocating the memory space. So let's say we are doing this free head. Now our head is empty. Okay, so now we need to put something into the head so that the head points to the first node. After deleting the first node from the list, the head points to the second node. So the second node address will be contained in the next of q. So we can write it as head equal to next of q. Okay, and this way that's all, right? So so to handle this next of head and all, we can use another pointer as well. But if you see clearly, it is just the steps in which we are doing. Like first we are updating the next of q as the initial head next, that is 200. Okay, and then we are freeing up the head. Okay, then that means we are deallocating the 100 space. Okay, and again what we are doing, after deallocating this 100 space, address space, we are then moving the head to the next of q. So the next of q is 200. So now our head points to the second node in the circular linked list. Okay, so that's all about this, and this is all about deleting the first node of the circular linked list. That's it. Thank you very much for watching. Next, we are going to learn about how we can delete the last node of a circular linked list.